Good morning, everyone. Thank you for joining today for an Azure Power Lunch. Just quick disclaimer, as we always do, just want to let you know that this call will be recorded and we are going to be placing these recordings on our YouTube channel. So if you don't want to be recorded and you can drop off now. Okay. So with that, our topic of discussion is Azure Disk Storage enhancement, and especially we're gonna it should be Azure Managed Disk Storage enhancements. So as you know, when we started with Azure in the very early on, we used to have only disk which you carve out of unmanaged disk. We call them now, which carved out of Azure storage blobs and things like that. They were just page blobs. Then managed disk came, which kind of hide all the underlying complexity, and we continue to enhance them. Initially, they were based on basically, standard spinning disk, standard disk, and then we added SSD, premium, and now ultra. So we're going to talk about some of the enhancements in this area, which is kind of some are latest and some are went to GA, some are available in preview. So the few things that we're going to discuss are shared disk, bursting. We're going to talk about how you can do an import and export of managed disk over private link, which is now available in preview. And also, we have some new SLA, and we're going to talk about those SLA first. So you know that we have single disk SLA initially only for the premium SD onward. So premium SD used to have I think it's 99.9% SLA with a single VM. So if you have a VM with premium disk, you get a 99.9% SLA. Now we are expanding it and announcing SLA for standard disk and standard HDD as well, which is based on the spinning disk. So this is kind of a big news. So now if you have a VM and just a single VM that is running standard SSD, you get 99.5 SLA. If you have a VM that is running standard HDD, which is the old spinning disk, you get 95% SLA. And this is once again, as we are making more and more enhancements to our reliability and scalability, so that these SLA kind of show our confidence in our infrastructure. Okay, so that's something to keep in mind. Azure shared disks. So this is basically something that we just took to GA. So first of all, what are shared disks? So there is a protocol SCSI PR, SCSI Persistent Reservation. That protocol allows you to compute instances or more compute instances to read and write to an attached disk, which is attached to all of these compute instances. Okay, and that's how you can create some very interesting kind of scenarios. For example, we used to have, when on-prem, still have clusters. I mean, that was something that that shared disk has made possible. So this kind of, when you have shared disk, so clusters or scenario where you need multiple compute instances accessing same shared storage, and not just the file storage, it is basically same shared kind of what we call same shared disk, attached disk storage. So this Azure disk shared disk allow you to do that. And this makes possible one of the very important workload, which is Windows Server cluster. So basically, this is kind of a number of customers who need lift and shift of their workload, especially SQL Server. You know, failover clusters. So they had SQL Server on failover clusters on-prem, and they wanted the same infrastructure in Azure for one reason or the other. So that's this enhancement or this shared disk feature make this thing possible. So now you can deploy these workloads in Azure by taking advantage of Azure Shared Disk. So these are, of course, in if you are using Windows, that's going to be using Windows Server Failover Cluster. So that support is there. If you are using Linux, so that's where you will be using a Linux cluster can use some tools like Pacemaker, and you can take advantage of those to build cluster for SAP workloads or any workloads that required the clustering technology, which was very popular and still very popular in a number of on-prem workloads. Okay, so just a few seconds to understand this kind of workload better. Um,
Nalin,
so
just a quick question. Is it available right now, the Azure Shared Disk?
Oh yeah, it's available, man. It's
Okay.
actually GA. I mean, it's
GA, okay.
available for some time. Yeah, it's GA.
Thank
So it is GA. So definitely, yeah. Okay. So how this failover clustering works? So basically, you have two VMs and you have this shared disk. And through this SCSI PR protocol, both of these VMs make an intent of reading and writing data to this shared disk. Okay. At this point, it is only intent. Okay, so they are like kind of saying, okay, we plan to write or read from this disk. But one of that VM, let's say VM1, gets an exclusive lock to read write. And at that point, it is writing data. This is doing a write lock, and it's exclusively writing to that disk. Okay. Any writes from the other VM will not succeed. So at this point, that VM is doing all the computing and there are no writes coming from the other VM2. Let's say something happens to VM1. At that point, it will leave. It will kind of lose its exclusivity, and VM2 will get initiate a exclusive lock to write on the target shared disk. So it will start writing to that. So that's how this kind of failover works, where you have two compute instances, and there can be more which are writing data to this particular disk. Okay. Any questions? Okay. So let's quickly move further. These are the ranges. How many shares uh, you can expect? So if for certain disk sizes, I mean, Ultra SSD, you have 5 maximum shares. Doesn't matter how big your disk is. Okay. And for premium SSD, it is only supported for P15 and above. And for P15 to P20, you can only have like um, how many how many compute resources can use it as share two. For bigger like P30, P40, P50, you have 5. So this is all that, I mean, you can see how big is your cluster, and then you can pick up appropriate disk. Just keep in mind, only supported for premium and ultra SSD workload. So just keep that in mind. Okay. So let's move further. Disk bursting. So Azure supports a feature called bursting, and bursting is supported both for disks at this point as well as VMs. You know that we have a B series VM which is burstable, and same we have now the bursting technology in support for uh, disk as well. So how bursting works? So I would kind of take a second on the bursting credit system and how this thing flows. So way the bursting works is you have, let's say that you have a disk And when we talk about this, we talk about IOPS and we talk about throughput. IOPS is how many read and write operation you can do, and throughput, which is megabits per second, is basically how much data you can move. And they are both related. So if you are kind of reading, writing large chunks of data, your IOPS may not be that high, but you may be consuming a lot of bandwidth. So both things kind of limit how your, what is the performance of your disk. And on top of it, you have the VM. VM has the same IOPS and bandwidth limits, throughput limits. So if your disk limits are higher than VM, it doesn't matter because VM is going to be the bottleneck. So with that, so let's talk about bursting. So let's say that the VM you have, the disk you have has a 500 IOPS limit and 60 MB bandwidth limit. So what will happen is, and let's say that your VM is running at only 10% of the capacity. Okay, the disk is running only 10% of the capacity. So all that extra capacity that you are not using, it's kind of get deposited in your account. So you are constantly keeping that um, that capacity, and that's continue to accumulate. That's, think of it, it's like you're saving. You're getting $100, you are only spending $10 or $90. Uh, let's say you're getting $100 every day, and you're spending $10, $90 is going into your bank. And then let's say you got some need. In the case of disk, let's say that some workload like a batch process or some workload came in which needs high IOPS. So what it will do is it will now withdraw from the bank. Whatever the capacity it has accumulated, it has reserved, it will start using it. And it can burst up to a certain range for 30 minutes. So let's say that kind of, and until unless all the capacity that it has saved is now consumed. So it will, and it can last up to 30 minutes. So that gives you kind of, a lot of savings. So instead of, let's say that you have workloads which are burstable. Like, I mean, they have peaks during certain hours. So, and I mean, and just to meet those peaks, you have to use disks which have high IOPS and high bandwidth requirement. With this capability, now you can save money. Now you can use a disk which kind of meets your regular demand, but whatever extra capacity that you have, you can save it and then use it when that peak comes in. Okay. So as you can see here, uh, these are the state. So first of all, when you are your disk is running, or it can be a VM as well. But since we are talking about managed disk, so whenever your managed disk is running below its capacity, okay. So whatever IOPS and megabits per are it is saving, it is saved as credits, okay. Then it is bursting. So at that point, it needs that IOPS, so it will use all the credit that it has saved. So all the money that you have saved, now you have to use it. Let's say you were buying a car or something, you used all that money. And then you came back to the normal, which is the IOPS that you were, that you support. So let's say it supports 500. So you are at those constant IOPS at that time. You are not kind of saving any credits. So any questions?
So Naveed, so for VMs to access the shared disk, does there any requirement that VMs should belong to same availability set or zone?
Yes, there is a requirement. They have to be requirement to proximity placement group, PPG.
And what does that mean, PPG?
If you see proxy placement groups, what it does is it placed VMs into the same physical proximity. Data center, we talk about when we talk about a region, we have zones, we have data center. If you spin up two VMs, they may be in the same VNet, but depending on how you configure them, they may be in different zones. In
Right.
this case, they have to be in the same proximity placement group, which makes sure that they are in the same data center, in the same zone, and in the same physical cluster.
Okay.
I mean, what we call physical stamp. I don't want to use the word cluster, physical stamp.
Okay. Thank you.
Okay, so that's the requirement for this sharing. Okay, any question on bursting?
So Navid, so whatever is unused, is it like a timeline that you're actually keeping that? So let's say let's say the example that you gave, the 90 you're not using. So like within a certain span of time, it's going to burst up to that limit, that whatever is not used. How does it actually?
No. It's just going into your bank account. So let's say you do not use it for a month or 2 months, but then suddenly a peak came in, and that will use it. So that will allow you to peak to a very high workload and then come down.
Okay, so whatever you save, it can go up to that limit.
Yeah.
Got it.
Yeah.
Thank you.
Oh, and by the way, just keep in mind, sorry, what I mean to say was whatever you save it, you will be able to consume it, but you will be able to still peak to a certain limit for 30 minutes. And let me show you this. This is the limit to each disk can go up to. So you can do bursting for these type of disk, P1 to P20, and look at that. This is the provision IOPS. So for example, if we look at P10, the provision IOPS are 500. Okay, but look at the burstable IOPS, 3,500. So almost 7 times. So you can burst for 30 minutes for this IOPS, depending on you have saved credits. Okay, this is very important to understand. If you are always running at 500, then bursting will not work. As I understand, it will work if you have, so basically you save credit and then burst based on that credit. It's like the same thing. I mean, if you don't do any saving, then it's hard to go on a vacation, I mean, yeah, you can use credit card, but it's different. Okay. Any questions on that? Okay. So let's move on. An interesting feature that they have announced, and this is once again, the more private connectivity. I mean, support for more and more enterprise grade feature. So we all know whenever you can take a VHD from on-prem and migrate it, what we call import export, to the cloud into a managed disk, vice versa as well. You can take a disk and bring it down. This is called import export. And there are AZCLI command that allows you, as well as I think UI features as well, which allows you to move this disk from on-prem into the cloud, so you can take advantage or do workload migration. What this feature allows you to do is restrict that import export and let it happen only over a private IP address. So what you will have to do is you will have to create a disk access resource. Please keep in mind that this is still in preview, and you have to get your subscription enabled for that feature. So there is a link. If you look at the resources, there is a link, and in that there is an email address where you have to send an email so that they can kind of enable that feature for your subscription. And at that point, what you will be able to do is you will be able to use this feature. So you will be able to create a disk access resource. You will do a private link for it, and you will do that private link to a VNet, And if that VNet is connected to on-prem, you will be able to use that VNet and your on-prem connectivity to push disks from on-prem into the cloud. And what you can do is you can also block that. So let's say that you don't want to move anybody to move disks. So you can block that. You can do a denial. And in that case, nobody will be able to push disks into the cloud. So for example, let's say that you were doing a migration. Once you're done with a migration, to for security or whatever reason, you said, okay, I'm no longer going to allow a migration of disks from on-prem into the cloud. So you can turn that off. So that's a very powerful feature. And once again, everything will happen over private connectivity, no public connectivity, all of that. So that's why this is kind of this is very powerful. So this is something that that is available currently in public preview. Okay. Any questions?
Nothing from the chat here, Naveed, so far.
Okay, that's good. That's good. Let me see. I think I had a. So here, let's see a demo of bursting. So I have this IO meter. I'm sure you have seen this tool. What this tool allows you to do is it allows you to test workload. So I'm going to use like a 4K workload, and let me show you this VM first. This VM, I have it here, and the disk is 128 disk size. So if we go here in this, this is 128, it should go up to 500, and it's just running on. So let's see if let's see how burstable it can be. So what we're gonna do is we are gonna do this 4K workload here, and I am going to go and hold on. Why it is not picking up this target? So I'm just targeting that disk, and let's run this test. Results display. I want it every second. And look at that. Look at the bursting. You see that? It's almost twice that load. 500 is the load IOPS that it can take, but it is way above the provision IOPS because this machine was sitting idle for a couple of hours. Okay, so it has accumulated all those IOPS and it's going to use it, and it can burst up to 30 minutes or till all the IOPS that it has accumulated are consumed. Okay, so this is, I just want to kind of show a demo to, convey the point. That's how it will use those IOPS in bursting mode. And by the way, just keep in mind, you can use burstable disk with non-burstable VMs as well as burstable VMs and vice versa. So that's that has no impact on one way or the other. Okay, just keep that in mind. Okay, any other question? Final question? Okie doke. Thank you very much, and hope to see everyone next week. Hope to see, and stay safe and stay healthy, folks. Have a great weekend, everyone.
Thanks, Naveed.